So I grew up building all kinds of things, mostly in the family workshop at first. And everything I built actually around the house was like primarily to make it more accessible. My dad was in a wheelchair and we lived out in the middle of nowhere in the 80s. And so there were no ramps or anything. Cars were hard to get into and out of. And so I didn't know it, but I was getting a crash course in product design for people, with disabilities when, from a very young age. And that kind of led me led me into a life of like engineering, like studying engineering, first chemical engineering and then material science. And always with an eye towards like, who is this for? What problem is this solving? And how can we do it in a way that really meets that person's needs in a way that also retains their dignity and identity. I think it's a really important part of design. So I found myself running a hardware company. It started actually like as a government project, building desktop sized manufacturing equipment for the classroom. And it was the same thing. It was like, how do we increase access to these tools that are typically very complicated, and not many people ever get to lay their hands on a CNC machine like we were building. But we took the approach of like, okay, what would a person who has no experience need to know in order to work with this tool? How can we create an interface which really opens doors to a new kind of technology? So I ran that company for 4 years and sold it and ran it for one more year. And then I decided to do what I do now, which is essentially get women ready for careers in manufacturing, whether that's partnering with manufacturers and thinking about what kind of training programs they need to set up, or, whether, specifically training women, just educating them on what manufacturing is. And the whole goal is again, to create points of access for people who have all the aptitude, but just haven't walked through the right door. And I'm always looking for, more people, especially people you don't typically see in tech, to help out with whatever projects that they're working on and share my expertise. And, having spent 5 years in manufacturing, I know a bit about supply chains and the design process. And I'm really excited to hear what your projects are, and in any way I can make the process maybe a little bit less painful, if that's possible.
Absolutely. Well, thank you for sharing. So we're just going to have these two amazing projects that Helen and Maya are going to be talking about. So what I will do is I will go ahead and have Maya, you'll go first. You'll have about 15 minutes. So if I stop you after 15, I'm not trying to be mean. I just want to make sure that we squeeze in time for everyone. And then once that happens, you'll have the 15. So you kind of just take 5 minutes to kind of talk about your project specifically, give Danielle time to kind of share about her thoughts, and then you guys can have dialogue, and then we'll move on to the next one. Okay?
Yeah. Sounds good.
Awesome. I'm going to put myself on mute. Sorry.
Okay. Okay. Yeah, so my project, as I mentioned on the project page, it's called Tomodachi, X2. Tomodachi means friends in Japanese. It's kind of a play on, it's a modern retro system. That's the basic summary. That's also the name, because, Amiga is also friends, but in Spanish. So it's kind of a play on that. Why the X2? Because it combines the Z80 processor and the 6502, what successor really, in one system, and some more magic. Because the whole thing is like, this whole 8-bit era, lots of people are just trying to keep those old 8-bit systems running, those old Commodore 64s and 128s, which are kind of rare, really. And finding those disk drives and keeping it working, and it still remains these old limited systems and availability. I mean, I bought a Commodore 64 recently, and it had the original SID synthesizer chip, just swapped out with one of those twin SID thingies. That's not cool, because you're like, I'm expecting an original system, and it's like slowly, it's this Frankenstein thing. What if you could just buy a new system that combines all of that in one system? So it has the Commodore 64 mode, Commodore 128 mode. It can be an MSX original, MSX2. It has all of the original synthesizer chips. It even has its own mode. Well, it's the native mode, as I call it, which has a RISC-V softcore. Combined with, well, you can use any of the synthesizer chips, but I decided to add a Yamaha OPL3. And someone already commented to me like, hey, it's a really cool synthesizer system that way. So I can use all those old synth chips from the 1980s in one platform combined. And you can use it as a RISC-V development platform, and you can use it for, well, as a productivity system if you really miss the early 90s or 1980s. Actually, it has lots of memory. You don't have the 64 kilobytes, you're not limited to that. You can actually use 16 megabytes for each of the Dual Z80 and Dual 6502 processors. So there's a lot of memory you've got there, and that's more like the thing, a big idea behind it was like, what if the designer from the 1980s had access to a bit more modern technology? And this is kind of what I came up with, because there are lots of those kits out there with a Z80 processor, or what is this Western design house W65C 816 with the 16-bit successor of the 6502. It's really popular. Lots of people are using it in projects, but in the end, it's just this one system with this one processor doing this one thing. And it will never be an MSX. It will never be anything other than what you design it to be. And I think that's really the thing about Tomodachi, flexibility. So you can use it as one of those classic systems, a bit faster maybe. I mean, who wouldn't like a Z80 clocked at 50 megahertz while being super scalar? It's going to blow lots of silver out of the water, and you can do new cool stuff, which you couldn't do back then. I think that's a really big selling point. And of course, having the native mode there, and in native mode, you can still use the Z80 processors and the other processors as co-processors. So basically, you have a 5-core system, you could say. Everything in one system, everything combined from 8 to 32 bits. So that's interesting, I think. So I'm looking forward to playing with it, and I hope that other people are also really interested in using it. It was my first FPGA board.
Yay!
So I've been slowly ramping it up, because I mean, it started a couple of years ago with a simple board, just nothing more than just an ESP8266 on a Node MCU board, sticking it into a header on my own custom PCB. And now I'm like, well, sure, I can do a FPGA fan out. I mean, we can't. I mean, 4 or 6 layers, same difference.
Ooh. Good for you. That's awesome.
I like a challenge. I mean, that's what you learn.
Yeah, that's really cool.
Be like, I mean, other people can do it. Of course, I can do it.
Mm-hmm.
Why would I not be able to do it? Because
so
others
cool.
can do it.
I just programmed my first FPGA this weekend. So
Great job.
yeah, it was good fun. So this is a really exciting project.
Mm-hmm.
Yes, especially something this ramp up the complexity, because I think there's all those different modes integrated. I have to implement this. I'll put a block diagram of the chipset. So basically, what's has to be implemented in the FPGA on the project page today. It's a bit late, I know, but it's finally there.
Well, I have a question for you, Maya.
Okay.
Sorry, is it Maya or Maya?
Maya.
Okay, Maya. So you write for Hackaday, right?
Yes.
So do I. I've been worried about entering the Hackaday prize. I haven't actually put my project page up yet because I'm a writer for Hackaday. Is that not a problem?
It's I've researched that, and I did not find anything in the regulations rules about being limited or anything. So.
Really, that's really awesome. I'm really happy to hear that because I've been worrying about that.
Yeah.
Okay.
And, yeah.
Okay,
so,
cool.
That is one of the first things that I did. I mean, I had this project running for a while, just as a private, because this, I mean, everybody is doing this, like this retro systems and making the next awesome system. Even like some famous people on some famous channels on YouTube, like the 8-bit guy. Like, yeah, well, there are lots of out there. They looked at some and no, we're going to make our own. You're still like, well, they're all going for the same 65C 816 chip, and they go to the same peripherals, and they come to the same thing, and you end up with basically just a 16-bit Commodore 64, I guess. That's the best way to describe it, and it's boring, you know. I think also because of the interesting chips, like those Yamaha synthesizer chips, they're not being made. Those SID chips, well, this is all old stock that people are slowly destroying in hobby projects. It's like I must do something with these chips, and they take them out of working systems, and then they put them in a custom PCB, and they find out that they're not as they thought. Destroyed. That's why in the FPGA, so all of the synthesizer cores, they're all simulated right now. It's just all implemented as soft cores. They can be implemented also as ASICs. I've actually been thinking, talking with a friend who works at a local university here. They have a small ASIC production capability departments, and to actually look into actually producing some new SID chips and maybe some of the OPLs. Because it's not super complicated technology. I mean, it's 1980s level.
Can I ask you, can I jump in a little bit?
Yeah.
I have a couple of questions. One of the questions is, so just to see if I understand what you're doing. So you're basically like taking the technology from the 80s, but you are creating a system like what you said. What if the developers from the 1980s had access to modern electronics?
Yes, but yeah, FPGAs maybe. It's,
yeah, totally. So, in my mind, that brings up a question, which is like, what is it about the 1980s that you're trying to retain, or that you want access? Like, what's the character that you want people to have to, you know, for it to still have that feel or whatever it is, but be with modern technology? And how do you keep that?
Well, the main thing, I guess, is I've noticed it actually is watching some of the younger people here at the Hackerspace play around with the Super Nintendo, for example, and first time inserting a cartridge, turning it on and being like, it started. So it's constant inexperience. It's like you turn a Commodore 64 on, there, it's there. MSX, you turn the power switch on, it's there. Like it immediately boots from ROM, and there in the basic interpreter or whatever it has there. And I think that is something which is really missing. That's a lot with those emulated systems these days. Like, okay, you can emulate it, but it's still just another SPC with Linux running on top of it on this big fat SoC, and you still have all the. It's not a real experience because it's not this instant on. It's not this low level. I spent probably too much time as part of another project researching the schematics for the Commodore 64 and Commodore 128, just to understand how they work. And the cool part, I think, is you have those schematics. You can look at every single detail there and understand it. Understand why they have those chips there, why they had those issues, why they went through those revisions. And I think that is something that's really missing with those, even with those the Amiga systems. You did not really have the magic anymore of like you have this user port, which is basically you plug something straight into the bus of the system. Like
I really like what you said. It's kind of like you're distilling out the user interface. Like the user interface to these old systems was really special. And I completely agree with you that an emulator is not the same. Like there's a physical aspect to it. There's like sound, there's like a responsiveness that's very specific to the old style of hardware. And I think that there's a lot of wisdom actually in the old user interfaces. And I also liked what you said about single purpose devices. I think that single purpose devices also have a level of accessibility that like a more complicated, like if you're like, oh, I'm making a computer, it can do anything for anyone at any time with any kind of capabilities. That's a lot harder for people to get into. I think there's a beauty to having a single purpose device.
On the other hand, of course, like the common systems, they were famous for having all of those cartridges with which you can extend the functionality of the system. Something which has been used for so many peripherals. It's but this, I think, the main thing about those old 8-bit systems, they invited people to hack them and develop new ways to use them, understand them. And just by having so much available, that's also why on the Tomodachi, I also want to have the cartridge slot. I want to have basically the same functionality. Ideally, if you have a Commodore 64, a 128 cartridge inserted, then it should immediately boot from that. I think that would be awesome.
That's great. I want to, of course, like get to whatever questions you might have for me. But one of the things that has stood out to me about the Hackaday prizes in the past and the people who have won, were like when you have a system like the one that you're building, which has a lot of options, they've gone through and chosen maybe one or two typical use cases. And like gone, like I built this system, but also like I built this instance of a system, which was like, whether it's, and it's kind of like in the eyes of the user, like this one is for the person who wants to experiment with, all of the musical capabilities of these 80s style systems. Do you have in mind any like use cases that you think like people would really resonate with your system if they're doing a certain type of exploration?
Well, I mean, if you look at the Commodore 64, for example, it was used for everyone, from musicians to business people. This luggable version of it, the SX. So it was used by pretty much everyone for lots of different purposes, for just doing taxes at home and everything it could be used for, and gaming. Obviously, I think it was used for gaming back then. I think, of course, like lots of the general purpose things, like doing spreadsheets in 80 columns or 40 columns is not really that much fun. So I think those really serious business applications would fall away. So you're more like, okay, the hobby is the people want to experience retro, but are also like interested. What if the Z80 process was like 500 times faster? So and like, okay. Because even today, there are lots of people writing software for those old systems. So they're really, you may have seen this one, Super Mario Brothers clone released for the Commodore 64 and immediately taken down by Nintendo, of course. But there are people doing lots of fun projects for the systems, developing new software. And this is kind of like the next step up. This is the upgrade for those old systems. You can still write the same assembly. You can still use the same tools. It's just going to be a whole lot faster, and you have lots more memory.
Okay.
That is the big selling point there. That you also don't have to keep repairing those old systems and have to retrofit them to keep them looking good. It's also with the Tomodachi system. I am currently thinking of making it in a mini ITX format, so it's compatible with lots of cases and easy to design for. And a friend of mine also mentioned, hey, you could also turn it into like a Commodore 128 compatible board, so you can basically slide it into those cases. That is also an option.
Yeah.
That's more specific, and I guess still this it's as general as possible, but without going to specialized, I guess.
Yeah. One of the things that I see, slaughter projects is they have a really broad scope and they run out of time. And so I'm wondering, how do you decide what to say no to? Like, do you have a critical path where you're like, okay, this is my, my minimum viable project that I want to do? And like, how are you making those decisions?
Well, this point, right from the onset of the project, I had this central idea. Okay, I just basically want to make a better Commodore 64. No, Commodore 128 basically, because the Commodore 128 is essentially everything about Commodore, the original Commodore systems combined in one system. Like you've got the Commodore 128 mode, 64 CPM mode, everything is there. And it's basically an upgraded version of that system, and I think that is a central focus. It's also why I have the Z80 and the 6502 because you really just want to, I guess, want to preserve that aspect, while also introducing this native system, not just limited to old processes. We're like, hey, modern RISC-V as well. It's also for people with no interest in the retro system. They're like, hey, it's still a cool system because it has all the stuff on there. It's relevant to me, and they've also played around with the retro stuff because it's still there. And I mean, the most expensive part of the BOM is probably going to be the FPGA. So those extra MPUs on there, they're not really going to break the bank. Let's put it that way.
What questions do you have for me?
Well, you know what, Danielle?
Go ahead.
Just to make sure that we have enough time,
sure.
We'll just switch to Helen, and I'll give her the same amount of time we gave Maya, and then at the end, maybe kind of answer.
Okay. Sure.
Okay.
Yeah, whatever you think.
That we fit it in. Okay, cool. Thank you, Maya. All right, go ahead, Helen.
Hello, everyone. I think I might just briefly introduce myself so you know what I am and what I am, who I am and what I do. My name's Helen Leigh. I am a hardware person. I do most of my work is around music technologies, either using gesture control or capacitive touch. I'm really interested in the creativity in making your own instruments and kind of the musical possibilities of sound making. I know that sounds really wanky, but I've done a number of projects in this space, one of which is actually a real project, and a lot of them are, my own projects. I worked with the artist Image on a dual control wearable instrument for children, and that they sew, wire, and code themselves, and that's available for sale around the world. Which is interesting because it takes sensor data and converts it into MIDI data, so you can control professional music software on your computer or, GarageBand with gesture, which is a really exciting thing. And it's like $33. So it's really, really cheap and slightly, it's a really cheap, easy way of using gesture as a controller on your computer. It's also got this isn't my project either, but it is my project, obviously, but it's not the one I'm putting in the Hackaday Prize. It's also got like chiptune capabilities as well, so you can work really nicely in classrooms with that. This one's kind of the opposite, the one I'm putting in the Hackaday Prize, in that it's taking MIDI from computer and then pushing it out into into an object, like a physical object. So this is the prototype board. Ooh, it's a circuit board, which almost works. This is the first prototype. It's called the Mini Automat. There's Dada machines. And it's an open source hardware. And what it does is it takes MIDI, and you'll see I've got like 6 little barrel jacks here, and it basically pushes MIDI data out to these bad boys. These are solenoids, which are motors which actuate in and out. And what you do with these is it becomes a modular percussive robot, essentially. So if you want to use your MIDI data, your so for example, you've drawn in GarageBand, you've drawn it in Ableton Live, or you've taken a MIDI feed from another musician, and you want it to output onto something. Say, for example, I don't know, like you can, it's not very good when my finger's using it, but when it's being actuated by the board, you can get these really precise, really cool sounding robotic instruments that you create the environment for, essentially. So you might be tapping on glasses, you might be tapping on wood, you might be, there's all sorts of different extensions, so you can get it to play beer bottles, you can do all sorts of really interesting things. And of course, because you're drawing the MIDI file, you can create really interesting, really precise, but somehow really human and really homemade musical instruments. So that's essentially what the Dada Machines does. It does also other cool things as well, but I'm going to concentrate on the music making functionality of it. It's a second version of a project. The first version is the Dada, like it's the big boy one. It's got 12 solenoids, it's got MIDI DIN and out. This one just uses MIDI on micro USB. It's powered separately by a barrel jack, and then it's got 6 solenoids. That's the motors on it. It's fairly simple. We've massively scaled it down from the original one to make it capable of being embedded into systems, so you can like set it up and leave it. The original one was much bigger and much more expensive and less hackable. So the aim of this one is to create a proper product, like a real product. So someone with no knowledge of tech and no knowledge, like a child, I've seen a child use these things. No knowledge of tech can come in, plug it in, make a tune on GarageBand, like set up their environment, their glasses, their wood pieces, whatever, and start making music and start altering music. It's a really powerful musical tool, and it's actually being used by a lot of people already. So our revisions are very much based on our current user base. But this one is also, we want it to be like a product, but we also want it to be made for hacking. So like every aspect of it is hackable in some way, but it isn't out of the box. I mean, it is out of the box hackable, but you don't have to be a hacker in order to use this. So at the moment it's Arduino compatible, and as of day before, it's now working with CircuitPython. So that's really exciting. So we want to be able to go to where people already are. So people already playing with microcontrollers that are using CircuitPython, or people who already have Arduino knowledge are able to just easily integrate this. So we just need to create a couple of libraries. So it's already got an Arduino library and the CircuitPython library. I mean, I need to make a couple of hardware changes. We just changed the chip to an SMD51. So it's currently got a 21, which is CircuitPython compatible, but it's not quite as fancy. So we're going to change the chip, etc., etc. We want it also to have like a MIDI in, like a small MIDI in, like a, what do you call it, a 1/8 barrel. I don't know what your measurements are. The small headphone size jacks on there. So basically you can like plug in any of the MIDI compatible instruments, for example, the Adafruit's trellis, or, keyboard, or, so you could play the different things that you've set up by touching your MIDI keyboard. Yeah, that's it really. That's the product. I mean, I should say that it's a collaboration with my next door neighbor. I'm currently in Chicago, but I live in Berlin. My next door neighbor Johannes and I are collaborating on this. You may know him from the music-focused open FPGA board Doppler, or the Dada Machines. So this Dada Machines was like a year ago. Not this one, the big one, the one that was aimed at music technologists, serious musicians. It cost about $500 for the whole set. This one's going to be $99, so it's a significant redesign, and a significant redesign in terms of like how like who it's aimed at. It's going to be much simpler. It's kind of aimed at families as well as music professionals who have a bit less money. So yeah, this base unit we're hoping to get it in at $99, and we still need to make sure that's feasible with the. But it's all going to be manufactured in Germany as well. We're going to make all of the hardware open source, and it's going to be it's going to be surrounded with a whole package of content. So of course there'll be the startup guide, but I'm also going to provide like probably 8 different projects of ways you can hack it. So for example, making it well, or using it with an Adafruit trellis as a sequencer, or whatever, you know. So basically, I mean, that's what I do for a living largely, is kind of create interesting documentation for hardware. So we're going to have like a series of videos. We've got a number of musicians on board who are going to help us develop the content as well. We're just wondering what this is. This little box is just a very hackable robotic music machine. We're pretty. I mean, we've got a working prototype. I mean, you can't see that there, but we missed off one of the ground cables, so we've had to hack it in and wire it in myself. And the micro USB slot is slightly wonky because we put it on ourselves on a pick and place machine. But it largely works, to be honest. I'm pretty happy with it. It works with Ableton Live, which is really cool, which is a professional music software. So you can do really interesting things with that. It also can actuate lights as well, so you can have like light shows to go along with it. So actually it would work in retail for interactive, like really good control of lighting systems. If you were, that probably needs a video to explain how that would work. But yeah, it's basically a really, really fast, really accurate, really reliable way of creating percussive instruments. There we go. Is that clear? Do you understand what the project is?
Yeah, absolutely. I mean, I feel like you said it's like a robotic instrument platform, which takes MIDI input, you know.
Yeah.
It does a lot of other stuff too, but like a way to I like to think about projects in terms of like, or any company or project or whatever, as like, what's your positioning statement? Like, what are you doing? Like, what does it do, and who does it do it for? Kind of. And I think that you're really close to that, which is awesome. It's funny. There's so much of, since I come from like a manufacturing equipment background, I watch a lot of videos on just factories and things that are operating. And I was like, oh, this would be such a fun way of like programming solenoid based like actuation for manufacturing, but using music. I'm like, and the way that I envision it, maybe this isn't how it operates, but I was like, oh, if there's 6 tracks in Ableton.
Yes, exactly.
And each one is a solenoid.
Well, it's not a track. It's so if you're familiar with Ableton, there's one track on Ableton, and then you draw on the notes. So for example, you might have C, D, E, F, G, A, and then you actuate at each note. So essentially, you're drawing like a MIDI piece of instrumentation, essentially. And we do have like velocity control being worked on as well, so that's pretty close. Which actually I don't think anyone else has done that. Like the kind of like precise velocity control of solenoids. Well, certainly not in the hacker community. I've not seen it.
Yeah.
Like I don't want to confuse the message too much. I think robotic instrument like that receives MIDI is kind of.
It's basically like robotic instrument platform that you program using.
Exactly.
Like you could even say like program using Ableton Live or similar software.
And I think, you know, we're really concentrating very hard on how to open up this little board as much as possible. We did test it with CircuitPython, which was really exciting. That worked. I mean, I'd love to make it I mean, my dream would be for me to be able to, once it's on CircuitPython, to be able to make it work with the MakeCode circuit, the MakeCode platform. Because being able to block code something like this would really open it up to, I mean, because I work a lot. I teach a lot, and I teach a lot of creatives about technology. So, you know, like I teach on a master's on music tech for musicians. So like I'm teaching them like what a circuit is, you know, and what a microcontroller is. So I'm used to using very, very basic language when I talk about fairly complex technologies. So for me to be, and I, you know, I think, you know, my philosophy is that all coding is coding, and that I see how many amazing creative things from non-coders or non-technical people come out of using block code. So I see a lot of artists using block code and creating incredible things. So actually, I think that layer of like this higher level of abstraction is just super helpful when you're talking about creating something. So that's my dream, but I don't know how achievable that is in the time frame. But it's certainly CircuitPython, and certainly because like the documentation for CircuitPython is really good already. But yeah, certainly CircuitPython and certainly Arduino. We already have like the Arduino headers on here. So yeah, we'll see. I mean, neither of it, like me and Johannes, we're part of the music tech community in Berlin, and like Johannes runs I guess like a manufacturing label, you know, like a publisher's or a music label would take other people's work and then help them get it to market. So we're experimenting with this. It's like essentially it's like an open source hardware for music technology label. So essentially we're helping other people with open source tech come to market, because Germany's got really great manufacturing. I mean, it's a bit more expensive, but we think it's really important to have central, you know, like local manufacturing. It's really important. So yeah, we're kind of like helping other people navigate that.
Okay.
But that's just an experiment. I mean, I don't know. You know, if anyone's going to have an open source music techware manufacturing collective, it's going to be Berlin, for God's sake. Like, the other thing I was really interested in talking to you about is about distributed manufacturing. So, of course, in these days of like tariffs and import nonsense, you know, something that we're really interested in doing is talking to other regional manufacturers and having partnerships where that makes sense. We've never done that before, but we're really interested in exploring what that looks like, and who the people we would be. Would it be Adafruit? Would we pay them to reduce? You know, would they? You know, I don't know. You know, mostly people just ship things other places, and I'm like, well, would it not just make sense to have some kind of distributed manufacturing network? But I don't know who's doing that. I don't know if people are doing it. I don't know if that's just a stupid thought I've had. Like, that's something I'm really interested in exploring.
I think that like so we cared a lot about when we manufactured our equipment, and it had, I mean, mechanical components, it had motors, it had electronics and all that, wiring harnesses, everything. And because we started out small, we needed to rely on local partners. And so we would just comb the network, Google things, talk to people, you know, who like find one machinist and they know all the rest of the machinists in the area, you know, that kind of thing. And really built out like the knowledge of the network that was in our area. And we found that we could get just about everything made here. Now the trade-off was price. But I think that when quantities are low, it doesn't really matter. Like, you know, if now for electronics, there's a difference, but for mechanical components specifically, like it didn't really matter. Like until we were ordering 10,000 of something. It was better to have a local partner, also because we could work more closely with them. And we could keep an eye on quality more closely, which mattered a lot to us in the beginning.
It is really important. Quality is incredibly important for us. We'd rather be more expensive and have like something that is really solid, that looks and feels expensive, you know? It's really, really important to us.
Is what you're like, are you wanting to sell the thing that you're manufacturing as like a kit, or just like a pull it
As a
out of the box and use it?
Pull it out of the box and use it.
Oh, okay.
Yeah, but with the hope that people will hack it, and many guidelines for people to get that screwdriver out, and we're going to make it completely hackable. You know, you can take it at, you know, you can. So this is the prototype casing. This is not what it's going to look like. So, but what we've done here is this the top is held on by the headers. You can just pull them right off, and then you've got access to all the Arduino pins. Well, all the digital pins and the analog pins. So actually, like, I mean, this is just a prototype, but the concept will be the same. It will be a thing in a thing that comes in a very nice box, probably, and it will probably be matte black. The original one was brushed metal, but we probably can't afford that. We were looking like maybe like a matte silicone casing. I think that would look kind of cool.
Well, what are your goals?
You can take it off.
Yeah. What are your goals with manufacturing it, like locally, or?
We would just want to be able to have like a sales channel that makes sense. Like, we want to be able to basically, like, for example, I mean, I've done this with my product that I made for Pimeroni. Like they manufacture it and we get a royalty, right? So that kind of model is something that's interesting to me. It's like a fairly hands-off model, and particularly in other territories. So we may decide we'd probably manufacture it ourselves in Europe, but in terms of like hitting America, we'd probably want like a deal, like to get a royalty-based deal.
Did you ever hear of Circuit Playground?
Yes.
It was a project our Simpson made a long time ago.
Circuit Playground.
I believe that Adafruit manufactures those and ships them. And
Circuit Playground Express.
It's similar. Like, I don't know, like, it's a similar like kit experience. You do have to do some work to get them to work, but like, it's, at least in terms of form factor, and complexity, it's probably pretty similar. Yeah,
Adafruit would be our number one choice. So it's just basically navigating those. We'll do a Kickstarter first. We had a we do have a successful Kickstarter behind us. We raised about $200,000. Not for this product, for a different product, but you still retain that community, right? And that product, the product that raised $100,000 is now on its print run, I guess. So I think we're currently working out how to pay for a whole other print run of the original product. But there are other products that have already come out within that line as well. The FPGA, open source FPGA board for synth design. There's a giant sequencer, which is about, this big, with like hundreds of buttons on it. But that's just been released as well. So this would be the fourth product from the collective group of random people doing things together.
Well, I can definitely, if you don't already know Phil and Lamore, I could put you in contact with them.
I don't know them. They're aware of my work, I think. But yeah, I don't know them. But I'm not ready yet.
Whenever you are ready.
Oh, they're like so awesome. I know. Yeah.
I want to kind of creep in real quick because I want to give Helen, by the way, amazing. Thank you so much for sharing. I'm going to give this open forum because I know we do have a little bit of time, and then I have to make some final boring closeout messages. But Maya, I know there were some questions that I think maybe Danielle had for you regarding your project, and then Helen as well, if you have some final. So I'll give us 10 minutes, so 5 minutes each to kind of wrap up specific questions that you may have for Danielle, and then the last 5, I will say the announcements.
Okay.
Well, I guess the whole thing about for the production side got already covered with Helen's things. I mean, similar for my project, obviously. But I think we've got different kinds of enclosures, because this is the computer cases, I guess. Like things like styling, is they get really into this industrial design thing. And I mean, of course, I can just make something up in just a CAD program. I mean, sure. But like, would it be a good idea to actually get a real industrial designer to work on that? Is it something you would recommend there? Or is it something you can just kind of wing and it shall probably work out?
It really depends on the level of polish. Like I mean, industrial design is a real discipline and it adds a lot of value. So I think it really depends upon your level of comfort with CAD. But I will say that the projects which have that extra level of design on them do better in the contest. But you know, that's sort of a personal choice.
Yeah,
Excuse me, I'm trying to think about if there's like a place where you could find less expensive industrial design. I know about like graphic design and all of that, but let me look into that actually. Contract industrial. Oh, actually, I do know an industrial designer who who has done some contract work before, but yeah. Okay. Yeah, it's one of those things where it's like you could spend a lot of money like paying someone to do it, but it would probably be better to find like a student who is really excited about, you know, like an enthusiast who will work for free just because they want to be associated with your project. That's probably the way that I would go. But even having a starting point of you mocking up something is good to then hand off to whoever it is, because then there's not so much that's lost in translation.
Yeah, otherwise you're starting off with those sketchy drawings on the back of envelopes and flexing those over or something and feel like all confused. What are you trying to show there?
One thing that I might recommend, so I used to lecture on a product design course in London, and the lecturers there were always desperately looking for briefs for their students. And actually they had a fairly high level. So like, I mean, so you could, if you have links into a university, you could write a brief and get people to do it as an academic exercise, and you can get some really interesting, like, honestly, like they're always desperate for real life briefs to work on. And you'd of course get that for free. And you'd be doing something good because you'd be teaching. You'd have to talk to teenagers though.
There's that. That's a word to try. I mean, local technical university here. Maybe. It's worth a try.
100% worth a try. Yeah.
Yeah, I think being able to speak about your project in a compelling way is like it's good practice when you're trying to draw more people to you and get people to collaborate and give you their time for free. It's like, you know, if you can speak passionately and clearly about what it is that you're doing, like it's worth so much, because you know, people will be like, oh, I want to be part of that too.
Yes. It's kind of less like, I mean, also why I wanted this to be an open project is because, okay, I mean, I don't mind making some money off it, but the first place is this project because I mean, one of my first memories are of the 80s playing those video games on Commodore 64 as a child. That really sticks with you, and that is something you just want to just give to others, like the new generations, and even some older people will want to re-experience that. I think, and just to be part of that process, I think that is, that's really the thing.
Where are you thinking about selling it? Are you going to do a Kickstarter or what's?
Well, I'm currently, I'm actually in the process of putting another project of mine through crowd supply.
Oh, cool. How's that going? Lots of people
Well,
are doing that now.
it hasn't been approved yet, so it
Uh-huh.
just submitted it, and they'll have to approve it. And if
Yeah.
it does, then it's kind of like this first cannery. I'm just letting it fly through this
Mm.
line there of crowd supply and see whether it drops that or not.
Yeah.
Like it, and the cannery survives, then I may actually use them as well for this project. Just
Nice.
make use of their system. And
Yeah.
their assistants, they also have an online store. I think they even do the warehousing stuff. So
Yeah.
that's like, because you don't want to drive every single day to the post office to mail off those boxes.
No,
I don't
definitely
want that to
not.
be my life.
No. Yeah, I think they're a really interesting addition to the, I guess, the crowdfunding world. I think they really fill a niche. Like,
Definitely.
yeah.
No, I just like it because they are more specialized. Like, you really want to build this technology, and you must important prototype before you can even apply. And it's not just not a Kickstarter, Indiegogo.
Yeah. Yeah.
It's just like, yeah, I've got this fake idea and the fancy CGI rendered video.
Yeah.
And
I think it's a great. I think it's a great concept. Yeah.
so I'm just like I said, I'm just about to try that, and I hope I like it, because then it might just work for Tomodachi project as well. Because
Yeah.
I mean, of course I can do the Indiegogo way as well, but a friend of mine actually went through that with Indiegogo, and I mean, you get money, sure. It's crowdfunding, it's totally valid, but you still have to do the whole PCBA stuff yourself and the whole selling stuff, and it's on your shoulders. So, and that's a lot of work.
It is.
Yeah. Well, awesome. I'm hoping that you, Maya, got some questions answered. I love the collaboration here. So, Helen, if you have any final questions, we have about 5 minutes and then we'll wrap up.
Okay, so it's more about the Hackaday Prize and like what kind of stage you'd like us to be at. I mean, because yeah, we've got a working prototype, we've got like a roadmap. You know, we're planning on maybe launching a Kickstarter at some point this year. We've got, yeah, basically, what kind of documentation do you need? Like, ideally, what kind of, you know, what kind of stage do you want us to be at? What kind of evidence of, you know, do you need us to present you with like our bombs and our manufacturing plans? Or is it just, you know, tell you what the price point is and here are the schematics and here's the story? You know, what kind of thing are you looking for?
I think the projects that do really well are the ones with the best documentation. So
Yeah.
definitely like a video demonstrating how it works in some use case is essential. And then we really look for extendability. So if it's to the, like, you know, there's like a question, like a whole section of the questionnaire, which is like, how possible would it be for someone else to pick up this project and run with it? And so having adequate documentation that shows like literally like, here's the bill of materials and here's the instructions for how to build it or how to use it. And like you were saying, you know, this is a focus of your career, you know, you create that kind of documentation. That's huge. That really differentiates a project from the rest. Because documentation is often a thing that's like not as fun as building the actual thing, you know, for many people. So
it's more important, like, actually. Like, you can adequately document a stick that you find on the floor and have a lot more fun than a badly documented microcontroller with huge amounts of power.
I think it's like the extensibility, the like demonstration that it's a fully like formed, baked thing, and then like how easily duplicated would this project be? And the idea is that it could be easily duplicated by someone.
Well, certainly easily hacked. We will like release the schematics, but I'm not sure about the board layout. Maybe just so, you know, we've seen other small indie hackers get completely ripped off and ruined by someone taking a board layout off of the internet and just replicating it. I mean, our friends at Beck Inductive have been pretty fucked by that.
Yeah.
So I don't know, like it's that kind of line between, we all are such big believers in open source hardware and open source software and, you know, open source documentation, but it's also, you know, we're a really small group of people. Like it's really hard for us for them to then be able to, if you can buy something that's basically the same from China for, you know, like a third cheaper, will do. I don't know whether that's something that we're still struggling with internally, and that's, yeah, we don't know basically. I mean, it's just the board layouts that, I mean, I'm personally in favor of doing it, but you know, I'm not the only person in the collective, so we're having internal discussions about whether we release the board layouts or not.
Yeah, it depends on, like, you know, what your overall goals are for it and how much is brand gonna do, who buys what, and I think that is something that is really hard for people to replicate.
Yeah, and the ease of which they can purchase it as well. I mean, to be honest, like, I mean, Adafruit released all of their board layouts, you know, but then Adafruit have the distribution channel, you know what I mean? Like, if we were able to be manufactured and distributed by Adafruit, then I think that might make things quite different than if we were just sat at home in our little shared office in Berlin going, look, we made this thing. Everyone's like, no, we don't care. Like, you know, it's something that we're struggling with. Okay. And would it matter if our Kickstarter had gone live or whatever before the prize, or was that cool with you?
I don't think that matters.
Yeah.
Yeah.
I guess the proof would be in the pudding, whether people want it or not.
Right.
Are people willing to part with money for it?
I think I've been doing it 3 years now, judging, and I don't think that I've ever seen any project that had a crowdfunding campaign associated with it.
I know, but this year it's supposed to be about product.
Yeah.
So, I mean, like, I don't want to roll myself out because I've, you know.
I don't know. Do you know?
I work quickly.
Yeah. Whitley, do you know if there's any kind of rules around that?
I don't think that there is. If there are, I think then I would have to like research, but from my knowledge, no. I believe that the Kickstarter project is completely separate from what you're doing here.
Because this is like documenting the design process, essentially.
Yeah. Exactly.
You know, which is really helpful for the community anyway. You know, but yeah, I think ideally I'd like to get it out before November. Ha 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 ha! We were supposed to have launched it last month. So
speaking of that, let me I just want to go over a couple things just for final submissions and all of that so we can just wrap up. Thank you so much, Danielle, for your advice. Anybody that knows Danielle knows that she is open and an open book, so I'm sure you guys really received some great mentorship. I think your projects are both really awesome. I would highly recommend that you structure your logs and descriptions, just like Danielle said, making sure that you guys are being very proficient in what you are putting out there, because that is a part of the judging criteria. Looked at, so just keep that in mind. We'll send you a YouTube link, so that you can see your recording and see your awesome face on camera. So we want to make sure that these sessions are definitely improving. So we'll also send a survey so you can let us know your thoughts on that. We are going to be asking that you send your final submission for the project by the 25th of April. So
April?
Yeah, I mean, excuse me. Man, my mind. August, sorry. 25th of August, August 25th. So make sure that your final submission is in there. And then also the finalists will be announced by the 9th of September. And then we'll do all final judging, and then winners will be announced at SuperCon on November 16th. So hopefully if you have not gotten your ticket, you get your ticket for Super Conference, which is November 16th, and it's that weekend. So we want to just make sure that you guys are there. And so mark your calendars, make sure that you're keeping up to date with everything. Thank you again for taking time out to be a part of this mentor session. Danielle, Maya, and Helen, you guys are amazing. Any final questions or anything?
Yeah, can I just ask for clarity? Can I ask that you go back to your team and ask for clarity on the Kickstarter question, whether we're or not we're allowed to go live?
Yeah.
And also whether myself and Maya being Hackaday writers, we're not employed by Hackaday, we're freelance, we write blogs for them sometimes, whether that's going to be an issue. Can we clarify that?
No, absolutely. I can probably clarify with the Kickstarter that it's not an issue, but
Okay, cool.
as a writer, I will follow up on that. But I believe that the only thing is I just need to make sure, because sometimes with staff, like obviously staff, we can't be a part of the project because we're paid by the company. So if you guys are just writing,
we're not staff.
If you're not staff or getting paid, then I think that you should be fine. But I will just, to make sure and double, triple check, clarify, and then follow up with you.
That'd be really